This is Dr. Saraswati from Avnashlingam Institute, Department of Resource Management. The topic for the day would be significance and scope of ergonomics, man-machine environment, system interaction. The primary concern of ergonomics is being the design of the workplace as a system so as to achieve the best possible performance from the human consistently and continuously. It is an interdisciplinary knowledge in relevant fields such as work physiology, biomechanics, psychology, engineering, systems design and cybernetics in order to achieve a formulation system to achieve the goals, to understand the functional requirements, to analyze the system, to design a new system and to implement the system. Thus, to resolve any problem of this nature at the workplace, ergonomics is most likely to offer a set of solutions which leads to increase in the productivity of resources and efficiency in the production equipment, safe working methods, improved health of the humans with minimalization of hazards, and design and maintenance of comfortable work environment. Ergonomics is defined as that branch of science that is concerned with the achievement of optimal relationship between workers and the work environment. It is also called as human engineering or human factors. It is derived from the Greek word ergon means work and nomic means natural law. It is a discipline concerned according to the human needs, and it deals with the assessment of human capabilities and limitations such as anatomy, physiology. We learn about the structure and functioning of the human body. Anthropometry gives information on the body size, and physiological psychology deals with the functioning of the brain and the nervous system. Ergonomics deals with the study of human and machine interface. Machine does not mean electrical device but all device. This is designed in order to create a comfortable work environment. One has to adapt both physical and psychologically to his work environment. Because of non-conclusive environment, nowadays people face many health issues. The scope of ergonomics. The scope of ergonomics is tremendously wide and is not restricted to any particular industry or relevance. Ergonomic move towards everything which engrosses people. Work system, sports and leisure, health and safety all symbolize ergonomic principles if well intended. The capability of people to do their job is influenced by the person's potential, that is physical and mental, job demand, physical and mental again, and the condition which could be physical and organizational environment under which the person is carrying out the job. The objectives of ergonomic is to augment the efficacy with which work and other human activities are carried out and to preserve or improve certain desirable human values in the process of health, safety and satisfaction. The aim of ergonomics is to increase and conserve human health and contentment and to optimize the human performance in a system standpoint. Ergonomic is concerned with both employees' well-being as well organization well-being. Ergonomics aims to make certain that human requirements for safe and proficient working are met in the design of work system. The keywords would be health, comfort and performance. It will be clear already that benefits of ergonomics can appear in many different forms: in productivity and quality, in safety and health, in reliability, in job satisfaction and in personal development. The reason for this breadth of scope is that it is the basic aim in the competence in purposeful activity, effectiveness in the widest sense of accomplishing the desired result without wasteful input, without error, and without damage to the person involved or to the others. It is not efficient to burn up redundant energy or time because inadequate thought has been given to the design of the work, the workspace, the work environment, and the work condition. It ensures that functioning situation is in harmony with the performance of the worker. In the view of complexity, it might seem that solution is to provide a flexible situation where human operator can optimize a purposely apt way of doing things. Unfortunately, such an approach is sometimes impracticable because the more well-organized way often not apparent, with result that a worker can go on be doing something in the wrong way or in the wrong condition for years. Thus, it is necessary to adopt a systemic approach to start from the sound theory, to set measurable objective and to check the success against these objectives. The aspects of ergonomics. There are 5 aspects of ergonomics, such as safety, comfort, ease of use, productivity or performance and aesthetic. Based on these aspects of ergonomics, examples have been given of how products or systems could benefit from the redesign based on the ergonomic principles. Safety. Today everything is ergonomically oriented. However, buying just a single chair which provides a good posture balance and less stress on the body is just not adequate. To prevent musculoskeletal injuries, one must buy an additional furniture component which are also responsible in decreasing the stress and the work-related injury. Similarly, the overhead cabinets or the over kitchen counters in a kitchen may be lesser in depth and the optimal height so that the person working may get adequate headroom and will not hurt himself or herself while bending over the counter. Ergonomic principles can help one to avoid injuries at home as well as at work. Comfort. It is extremely important that products like chairs are designed with ergonomics in mind. Chairs should be comfortable for the child, supporting his back and allowing his feet to touch the floor. And in case of task lighting for a study table, some task lights are extremely bright as compared to the surrounding and can cause glare and discomfort to the user. Ergonomic principle could redesign this based on the contrast principle. Third is the use of ease. Seated on an ergonomically designed chair and work with a computer, the height of the chair must be adjusted accordingly. It is important to place a computer monitor at the level where it does not produce stress on the eyes or the hands. The top of the screen should be ideally such it is just below the eye level. When sitting upright, this positioning will not produce any neck or shoulder pain or eye stress. Similarly, microwave ovens, place them at a height that is much lower below the eye level makes it difficult to check while cooking. This could be addressed with the principles of working heights in ergonomics and aptly placing it at the ease of the process. Productivity and performance. Ergonomics can potentially be used to improve the productivity as well. The kitchen is typically the most used room in any house, and an efficient kitchen is typically a key point in having happy life. There is an ergonomic correctly working height for each type of work, and the work counter can be designed to maximize the performance and reduce the work stress by considering both ergonomics and productivity together. Aesthetics, and this concern our senses and our responses to any object. If something is aesthetically pleasing to you, it is pleasurable and you like it. It is an integration of function, usability and aesthetic in design. Example, switchboards may be placed at an appropriate height with the help of ergonomic principle so that they are consistent in height and therefore easy to locate and do not become spotchless in the interior elevation, thus letting the interior look pleasant while not only being unduly empathetic on the wall. Ergonomic is the study of interaction between people and machine and the factors that affect the interaction, and the main purpose of this ergonomic is to improve the performance of the system by improving human-machine interaction. This can be done by designing in better interface or by designing out the factors in the work environment, in the task or in the organization of work that degrade the human-machine performance. Now, the next topic would be ergonomics is beneficially applied in subsequent three areas. One would be design of man-machine system. A man-machine system is a system where one or more working men, human beings, work in relation with one or more machines, devices or equipment. Thus, a worker drilling a hole in a job or a person using a hammer to drive a nail in a wooden table, like an article being manufactured, an example of a man-machine system as far as ergonomic is concerned. Such system could be productive system as well as service system such as a post office or a firefighting system or a dispensary. Ergonomics is applied to adapt such system so as to provide maximum job satisfaction and comfort and minimum physiological and mental load to the operator of the system. Second, the design of the consumer good and the service system. Ergonomics is applicable in the design of consumer good, starting from the design of toothbrush and the other items like dining set, sofa set, kitchenware, household fitting table, shoes, etc. Similarly, protective equipment such as safety goggles, adverse weather and space clothing, gloves, crash helmets and firefighting and industrial hazard protection appliances, etc. should be also economically sound. Third, design of the working environment. While designing the proper working environment for workforce or the workers at work, the various factors related to ergonomics such as human endurance of illumination, pollution, noise, heating and ventilation should be taken into consideration. This aspect should be taken into consideration at each stage and right design up to the real utilization of the actual service. All factors concerned with the environment such as design of workbenches, public transport, road systems, town and country planning personnel and neighborhood as well as airport, etc. should be subjected to ergonomic analysis. So system can be improved by 1. Designing the user interface. It should be more compatible with the task and the user, which is easy to use and more resistant to the errors. 2nd, change in the work environment that is safe and more appropriate for the task. 3rd, change the task being more compatible with the user. 4th, change the way of work environment is organized to meet people's psychological and social needs. Work environment can be improved by eliminating vibration, noise and providing good seat, desk and ventilation lighting. So introduce a system or the task with a procedure that the people using it are already familiar with it. Our work organization can be improved if the workers are permitted to work at their own pace. Psychological stress would be reduced in this case. Eliminate the aspects of system that are undesirable, uncontrollable, unaccounted for. They get fatigued easily and the people tire unnecessarily. Due to bad interface, people are prone to accidents, injuries and more errors do happen. This can also lead to the user difficulty due to inappropriate combo of subtasks that are cumbersome and unnatural. Inefficient worker produces suboptimal output. In ergonomics, injury and poor quality, increased human errors are system problem and not the people problem. A solution to it would be in redesigning a better system than man management. Now we look into the man-machine system, that is the MMS. Always has a man subsystem and an user interface UI. These subsystems can further be divided into smaller and even smaller elements as necessary, and depending on the particular aim of the analysis, human factor is the system concerned with the relationship between human being, machine and the work environment. The objective is to obtain optimum balance between the human capability and the demand of the task. The man-machine relationship is the central core of human factor. The man and the machine may perform similar functions. Both can have certain capabilities and limitations. Both in words, that is man and machine, which benefits the human operator and enhances the overall system performance, is a primary aim of the human factors as an ergonomic discipline. Few examples of man-machine system would be a keyboard operator on the computer, a pilot flying on an aircraft. Interface between man and machine. When using a tool or a machine, we interact with it through the interface, which could be a handle or a steering wheel. We get a feedback via the interface, which can be a compact screen. This way, the interface determines how easily and safely we can use the machine. Human-machine system. System is a set of elements and there is a relationship between these elements and the boundary around them. System comprises of people and machine that perform a function in a specified combo and get some form of output. In ergonomics, human is a part of the system and should be fully taken into consideration at the design stage. So, human requirements are prime and the requirements in general are as follows, like equipment should be usable and safe. Tasks are compatible with the people's expectation, limitation and training. Environment should be comfortable and appropriate for the task. Work organization should recognize the people's social and the economic needs. Man-machine interaction. The performance of the worker in an industry depends on the interaction and the interrelationship of the worker with the machine or the equipment and the environment. A production unit is usually a man-machine integrated system performing under the environment envelope. The environment refers to not only the ambient condition of the temperature, humidity and noise, etc., but also the arrangement of the layout, facility, display and the control. Thus, human factor engineering is that endeavor which seeks to match human with the machine, equipment and facility so that their combined output will be efficient, comfortable and safe. Complex information is processing and decision-making efforts for effective control. It calls for the interaction of equipment designers with specialists in the field of work design. Physiology and biological sciences are also involved in this. The human subsystem, for example, consists of anthropometric, physiological, perpetual, cognitive and emotional. Subsystems can also be further divided into smaller elements if necessary. Now, what could be the determinants of MMS system performance? The objective of every organization to introduce ergonomics is to increase the performance at the required level of quality and safety. There are several factors that determine the man-machine system performance, which are briefly described as operator's ability. It is based on two factors: selection and training of the personnel. The system design is also based on two things: equipment and display, and system operation, which is based on the three parameters that include workload, communication channel, and maintainability. A simple man-machine system. After starting the machine, the man will receive a certain information from the machine, either in the form of a dial or display, etc., designed for that purpose, or by observation of the machine itself. The man will then process this information and make decisions with regards to the action he should take. He may manipulate controls or attend the machine in some way or the other so as to affect its behavior with the desired manner. Both man and machine are subject to certain inputs. The efficiency with which the man functions depends on the environmental factor and on his own characteristics such as age, motivation, training, and his experience, as well on the efficiency with which the machine provides the information feedback and accepts the controls. Now, what could be the classification of the man-machine system? The man-machine system may be categorized under the following basis. One would be nature of the man's involvement in the system, which is again classified into a closed loop system and an open loop system. The second would be a degree of man versus machine control, which is again subdivided into manual system, semi-automatic or mechanical system, and automatic system. A closed-loop system requires continuous control and feedback to function successfully. Example would be a man flying on a boomer plane or a fighter plane. Feedback is essential in order to correct errors, if any, through continuous control. An open loop system is one which is once initiated or started needs no further control by man, or at least cannot be further controlled. Example, firing a bullet from a revolver. The path of the bullet cannot be continuously controlled. A manual system is essentially a man-directed system. Example, worker cutting a mild steel bar using a hand hacksaw. A large variability is possible in the manual system, as every worker may select a different method or motion to do the same job. A mechanical system is more complex and inflexible in nature than the manual system because it has got the components which are well integrated. The machine component, which is power driven, and human activity is the information processing, decision making, and controlling. An example of mechanical system is a driver driving a car. An automatic system is still more complex system in which all the operational functions are being performed by the automatic devices. Operational functions are sensing, information processing, and decision making and action. The man does the task of monitoring, programming the function, maintenance, and the upkeep. An automatic telephone exchange is an example of this particular system. A perfectly reliable automatic system does not exist at the present. What could be the characteristics of man-machine system? This system could consist of man, machine, and the environment. And this is an artificial system and specifically developed to fulfill a particular purpose. It has got specific inputs and outputs which are appropriately balanced. It is variable in size and the capacity, and in its dynamic in its performance. Subsystems of man-machine system interact and affect each other, and these systems become more efficient when the output results are fed back to the system. And lastly, the environmental factors influence the performance of this particular system. Man versus machine. Man is generally better in his ability to be creative, develop entirely new solution, make subjective estimates and evaluation, apply principles of solution of varied problems, reason inductively, generalization from observation, select alternative modes of operation if certain modes fail, draw upon varied experiences in making decisions, store large amount of information over a long period of time, sense unusual, unexpected events in the environment, sense very low levels of certain kinds of stimuli like visual, auditory, taste, etc., recognize pattern of complex stimuli which may vary from the situation to situation. Machines are generally better in their ability, like machines can perform many different operations simultaneously. They apply huge amount of force suddenly or smoothly, can be extremely precise, sense stimuli that are outside man's normal range of sensitivity such as X-rays, radar, wavelength, and ultrasonic vibration, store coded information quickly and in substantial quantity, mark rapid and consistent response to data output, perform repetitive activities reliably, maintain performance over extended periods of time, maintain efficient operations even in those environments under which man cannot work. There are three aspects that are man and machine system. One would be design of information display, design of control, environmental factor. Now, technical safety is very important ability of subject to man-machine technology operations to perform this function without any hazardous situation for person or the environment hazardous situation in such circumstances in which a person is exposed to a hazard. Now, what could be the relation between safety and technical risk? Technical risk is defined as the combination of the probability of occurrence of harm and the severity of the harm, weight factor risk management, or in other words, control the risk is based on 3 points of identification of hazardous, risk analysis, reduction and or elimination of risk. Now, the complex method of risk evaluation in the workplace. This method of risk evaluation is directly in the workplace, was developed in the Section Machine Safety Working Group for mechanical, physical and chemical risk. Such methods must be simple and easy. Several components of the whole system can be neglected and the other components are very important, and necessary system in this meaning is one or more complex of the components which perform various functions. Compatibility. Compatibility between the user and the rest of the system can be achieved at a number of levels, namely biomechanical, behavioral, psychological and cognitive levels, etc. To assess the demands placed by the technology and the environmental constraint, weighing them against the capacity of the user. Ergonomic entropy is a disorder due to the lack of compatibility in some or the all interaction. What could be the reasons for such incompatibility? Requirement of optimum function was never considered at the designer stage, or inappropriate task design and lack of prototyping. Interactions between the work system. There are 6 combinations of man, machine and environment. They are human versus machine, and this is one in which the man gives it to the machine. Control system of the machine and application of force are good examples. Human versus environment. Human emit noise and carbon dioxide. Now, man versus human, feedback and display information. This is the output that a man gets from the machine. Example, it could be the vibration from the machine and the acceleration from the machine. Machine versus environment, change in the environment. Example, the noise of the machine, the gas or the heat that is emitted from the machine. Environment versus human. Environment influences the human ability to interact with the machine and remain as a part of the work system. Noise, smoke, heat that comes from the environment can affect the human in both physical and the psychological aspect. Environment versus machine, the next one, affect the function of the machine and overheat or freezing of the component. These are the simple basic work system. This system is applicable to one person, machine and an environment wherein all the 6 directions of the above mentioned is possible. Of the 6, 4 involves human to human and versus machine and the environment, which means that it could be human versus machine and human versus environment, human to human. The next would be machine versus human and the environment, which could be machine versus human and machine versus environment. Each of this interacts directly or indirectly with the others, and application of ergonomics enables it to function better by improving the interaction between the user and the machine. To conclude, ergonomics is a systemic study of the people at work with the objective of improving the work situation, the working condition and the task performed. The emphasis is on acquiring relevant and reliable evidence on which to the base recommendation for changes in specific situations, and on developing more general theories, concept, guidelines and procedure which will contribute to the continually developing expertise available from ergonomics. Thank you.